let's have a look at light passes. Right now I'll be just demonstrating how to do an RGB light pass, which is basically splitting some of your light sources into the RGB channels. In my scene I have a key light, a rim, and a top light. What I'm going to do is split those three lights in the RGB channels for that image. The first thing I do is to select those lights and create a group for each one of them. Also note that it is possible actually for several lights to be considered as one light source. Let's say you have a spinning light array, you can combine that as one group and Janus will treat it as one light source. In this case we want those three lights separated, so we have three different lights, three different groups. Alright, now let's say I want to base off I want to go and create a light pass for my character. So I'll duplicate my original beauty pass for this one. So I'll create and say duplicate. So once I've duplicated that, I'm going to turn off the buffer so that I don't get confused with it. I can just probably just take that off and then put here, this is my light pass for character. Okay, what I want to do is to associate these three with this render layer. So add association with selected groups. So now I have this associated. Now Janus will detect whether or not these are actually lights because it will actually go and search the items here. So after that happens, go over to the C command type over here, look at light pass diffuse right there. Now what this does actually, if I have a look over here at you see this is actually a command type, and we can access what a command type does by going over to the configure menu and edit Janus command types text. This will bring up the text file that holds all the commands for a particular command type. In this case I'm going to look at light pass diffuse, which is this, and I'll just briefly explain what's going on. Inherit bty raw, inherit bty2. This bty raw is basically the standard command or standard setting for all beauty type like passes, in which that everyone else is turned invisible while the target group is visible basically. And bty2 is kind of a complicated explanation, but safe to say that the reason why it's 2 is because there were some inconsistencies with lightwave cameras needing a different way of approaching matte objects and how they react to the alpha channel. So I inherit these two command types, and then I add something new that's specific to the light pass diffuse. In this case, I use this command. What it does is actually do a partial override. It uses a partial override called diffuse, which disconnects every other parameter of that surface and just leaves the diffuse there, giving you a diffuse pass. In this line it says light pass on, which basically tells Janus to split all those three lights that we've just associated and turn them into different colors, giving you that light pass. I've also added a ambient intensity 0 because we want to make sure that the light pass is accurate. We don't want ambient intensity muddling the solution. And for last, we put rad enable off to make sure that, again, just like ambient intensity, there is no radiosity in the scene when we do that light pass. Okay, so I'm going to close this. So we have, that's what's happening inside. In just one command type, many things start happening. So I just want to show you how this looks like when I render it. And this is our light pass. If I go and extract the red channel, you see that's where the red light's coming from. The green, kind of similar to the red. Go to the extract channel, blue, and the light's coming from the other way, including the shadows. Now, let's look at the light pass for the specular response. So I'm going to duplicate this using a shortcut, and instead of light pass diffuse, I will go for light pass spec, and then I will render this off. And so this is the specular response of the lights. Again, I'll extract the red. This is the specular response over that light, green, different, and the blue, which is the other light, the key light actually.